Logarithm, Part 2. By Easy Maths. Welcome to the second part of our logarithm lesson. Here, we are going to treat the logarithm and anti-logarithm of numbers greater than 1. If you are yet to watch our first video on standard form, we encourage you to do so before watching this, as it will help you to understand this better. Logarithm and anti-logarithm of numbers greater than 1. The logarithm of a number has two parts. 1. Characteristic, this is the integer part. 2. Mantissa, this is the decimal fraction part that you get from the logarithm or log table. In log 380.5 equals 2.5804. 2 is the integer or characteristic, while 5804 is the decimal fraction or mantissa. 2.1 Logarithm of numbers greater than 1. For numbers greater than 1, you can use any of the two methods below to get the characteristic. Method 1. Express the number in standard form. The power of 10 is the characteristic. Method 2. Count the number of digits in the integer and subtract 1 from it. Whatever you get is the characteristic. Example. Find the characteristics of the following numbers. A. 238. B. 5329. C. 7. Solution. Method 1. A 238 equals 2.38 times 10 raised to power 2 in standard form, so the characteristic is 2 since the power of 10 is 2. B 5329 equals 5.329 times 10 raised to the power 3 in standard form, so the characteristic is 3 since the power of 10 is 3. C7 is equal to 7.0 times 10 raised to power 0 in standard form, so the characteristic is 0 since the power of 10 is 0. Method 2. A 238 has three integers. 3 minus 1 is equal to 2, so the characteristic is 2. B. 5329 has four integers. 4 minus 1 is equal to 3, so the characteristic is 3. C7 has one integer, so 1 minus 1 is equal to 0, so the characteristic is 0. We will be using the most commonly used logarithms, which are logarithms to base 10. It is called a common logarithm. We can express any positive number as a power of 10. Example. 10 is equal to 10 raised to the power of 1, 100 equals 10 raised to the power of 2, 1000 equals 10 raised to the power of 3, 10,000 equals 10 raised to the power of 4, 100,000 equals 10 raised to the power of 5, and so on. These powers of 10, that is 1, 2, 3, 4, 5 and so on, are called logarithms to base 10. That is, number equals 10 raised to the power of logarithm. We can get the logarithm of numbers from the logarithm table using any of the two methods below. Method 1. These are the steps to follow. 1. Convert the number to standard form A times 10 raised to the power of B. 2. Find the log of the A part of it, that is, express A as a power of 10. 3. Apply multiplication law of indices, that is A raised to the power of D times A raised to the power of C equals A raised to the power of bracket opens, D plus C, bracket closes. Example. Find the logarithm of 380.5. Solution. Following the steps we stated earlier. First, convert to standard form, that is 380.5 equals 3.805 times 10 raised to the power of 2. Then, find the log of a. Part of it, that is express a, as a power of 10. Here, a is 3.805. Recall that we indicated earlier that the logarithm of a number is made up of the characteristic and mantissa. So you get the characteristic with any of the method we stated earlier and get the mantissa from the logarithm table. To get the log of 3.805, it has only one integer, so the characteristic is 1 minus 1 is equal to 0. To get the mantissa from the logarithm table, for 3.805, you check the logarithm of row 38 under column 0 and add the number there to the number under column 5 in the difference area. The number on row 38, under column 0, is 5798, while the number in the difference area under column 5 is 6. So, adding the two of them, we have 5798 plus 6 equals 5804. So the logarithm of 3.805 is equal to 0.5804. 0 is the characteristic we got earlier, while 5804 is the mantissa we got from the logarithm table. So 3.805 is equal to 10 raised to the power of 0.5804. Recall the form, number equals 10 raised to the power of the logarithm, as we stated earlier. Firstly, we also stated that 380.5 equals 3.805 times 10 raised to the power of 2. So, 380.5 equals 10 raised to the power of 0.5804 times 10 raised to the power of 2. Applying the multiplication law of indices, a raised to the power of d times a raised to the power of c equals a raised to the power of bracket opens, d plus c, bracket closes. 380.5 equals 10 raised to the power of bracket opens 0.5804 plus 2 bracket closes equals 10 raised to the power of 2.5804. So 380.5 equals 10 raised to the power of 2.5804. So, log 380.5 equals 2.5804. Method 2. This method is recommended as it is easier and faster. You have to follow the following steps. 1. Get the characteristic of the number and write it down, then put a decimal point on its right side. 2. Get the logarithm of the number from the logarithm table and write it on the right side of the decimal point. Example. Use the logarithm table to find the logarithm of the following numbers. A. 238. B. 5329. C7. Solution. Following the steps stated earlier in method 2. A. 238. First, we get the characteristic, write it down and put a decimal point on the right side. The characteristic is 3 minus 1 is equal to 2. Then, we get the logarithm from the log table and write it on the right side of the decimal point. That is, we check the log table for row 23 under column 8, which is 3766. So log 238 equals 2.3766. B. 5329. The characteristic is 4 minus 1 is equal to 3. From the logarithm table, we check row 53 under column 2, which is 7259, and under column 9 in the difference area, which is 7. Adding 7259 and 7, we have 7266. So log 5329 equals 3.7266. C7. The characteristic is 1 minus 1 is equal to 0. From the logarithm table, 70 under column 0 is 8451. So log 7 is equal to 0.8451. 2.2 Anti-logarithm of numbers greater than 1. We can also be given logarithms of numbers and asked to find the numbers. This is called anti-logarithm. We also get this from the anti-logarithm table. The characteristic tells us where the decimal place will be while we search the mantissa on the anti-logarithm table. Here we do the reverse of what we did to get the logarithm of numbers. To get the anti-logarithm of a number, we follow the following steps. 1. Check the anti-log of the mantissa part of the number and write it down. 2. Get the characteristic of the number, that is of the original number, and add 1 to it. Whatever you get should be the number of integers in the number you got from the anti-logarithm table. If the number of integers in the original number is 2, you place the decimal point after 2 of the digits in 1 above, that is in the number from antilog table, and so on. Example. Find the numbers whose logarithms are or find the anti-logarithms of the following numbers. A. 2.3766. B. 3.7266. C. 0.8451. Solution. A. 2.3766. First, check the anti-log of the mantissa. Mantissa is 37660 on the anti-log table. We check row 0.37 under column 6 to get 2377, and under column 6 in the difference area, we have 3. Adding the 2 gives 2377 plus 3 equals 2380. Then, we get the characteristics of the original number and add 1 to it. 2.3766 is the original number we are working on. As explained earlier, 2 is the characteristic, while 3766 is the mantissa. Adding 1 to the characteristic 2 gives us 3. This tells us that the number 2380 we got from the antilog of the mantissa should have 3 integers, so the decimal point should be after the third integer, going from left to right equals 238.0. B. 3.7266. Checking the antilog table, for row 0.72 under column 6 and under difference, column 6 gives 5321 plus 7, which is 5328. The characteristic is 3, adding 1 gives 3 plus 1 is equal to 4. This means the number has 4 integers equals 5328.0 equals 5328. C. 0.8451. Checking the antilog table, for row 0.84 under column 5 and under difference, column 1 gives 6998 plus 2 equals 7000. The characteristic is 0, adding 1 gives 0 plus 1 is equal to 1. This means the number has 1 integer equals 7.000 equals 7. Note, to check the antilog of numbers on the antilog table, you check from the decimal point, but to check the logarithm of numbers on the log table you check from the first significant digit. We have come to the end of this video. The next video will be on logarithm and anti-logarithm of numbers less than 1. Please subscribe, watch, and let us have your comment or review. If you have any question or topic you want us to treat, kindly put it in your comment to enable us to give it priority. Thank you.